Hello everyone, welcome to my channel. In this video we are going to discuss the last 6th, 7th, 8th, 9th and 10th question of Feb March 2020 Pure Mathematics 3 paper. So let's start. So the question number 6 is the variables x and y satisfy the differential equation this. It is given that y is equal to 0 when x is equal to 1. So we need to solve the differential equation obtaining an expression for y in terms of x. So first we will start solving with this equation given, and we can write it by the cross multiplication it as 1 plus 4y square is equal to 1 over e to the power x dx, or and we can integrate them. Integrating both the side, we can get it as dy over 1 plus 2y whole square is equal to integration of e raised to the power minus x dx. And when you integrate, we can see it is of the type 1 plus x square, so it is going to be tan inverse 2y and multiply by 1 over differentiation of 2y, that is 2, is equal to e raised to the power minus x, integration is e raised to the power minus x upon minus 1 and plus a arbitrary constant. And now we can rewrite it as 1 over 2 tan inverse 2y is equal to c minus e raised to the power minus x. Now we need to find c, and we can get it by this condition. The condition is given when y is equal to 0 when x is equal to 1. So we are going to put it here. So 1 over 2 tan inverse 0 is equal to c minus e raised to the power minus 1, or we know that tan inverse 0 is 0, so this gives you c value as e raised to the power minus 1, and hence the equation, or you can say expression for y in terms of x, we can rewrite this as 1 over 2 tan inverse 2y is equal to e raised to the power minus 1 minus e raised to the power minus x, and hence we can rewrite it as tan inverse 2y is equal to 2 times e raised to the power minus 1 minus 2 e raised to the power minus x, or 2y can be written as tangent of the right hand side minus 2 e raised to the power minus x, or finally we can write it as y is equal to half tan 2 e raised to the power minus 1 minus 2 e raised to the power minus x, and hence this is the expression, or we can, I hope that is clear. Now let's discuss the b part of it. B part of it says that state what happens to the value of y as x tends to infinity. We have just got y is equal to half tan of 2 e raised to the power minus 1 minus 2 e raised to the power minus x. We know that e value is 2.78 something, and hence when x tends to infinity, minus x will tends to minus infinity, and hence e raised to the power minus x tends to 0, and that's why y will tends to 1 upon 2 tan of only 2 e raised to the power minus 1. So this is the one part of it. Let's do the next part. Seventh question is the equation of curve is x cube plus 3xy square minus y cube is equal to 5, and we need to show ddx of y, differentiation of y with respect to x is x square plus y square over y square minus 2xy, and we can see y is given implicitly, So we are going to differentiate both the sides of this curve, and hence we will get 3x square plus 3 into, this is product rule, x into 2y dy over dx plus y square as it is, and differentiation of x it is 1, minus 3y square into differentiation of y is equal to 0, because constant differentiation is always 0. We can see 3 is common everywhere, so we can cancel 3 from everywhere. Now we can rewrite it as x square plus y square plus 2xy dy over dx minus y square dy over dx is equal to 0. So let's transfer x to xy and dy over dx minus y square dy over dx to the other side. We will get y square minus 2xy dy over dx. This gives you the final answer, and hence it is dy over dx is equal to x square plus y square over y square minus 2xy. I hope it is easy and clear. Let's do the B part of it. And it is given that you need to find the points, coordinates of points on the curve where the tangent is parallel to y-axis. We know that when tangent is parallel to y-axis, suppose this is x-axis, this is y-axis, if these two are parallel, it means this line will be perpendicular to x-axis. Hence we can say that dy over dx should be 1 over 0. Why? Because we know that if our tangent is parallel to x-axis, then dy over dx is 0. When it is parallel to y-axis, or you can say perpendicular to x-axis, then it would be 1 over 0. So now we are going to equate it. So from first part we have dy over dx is equal to x square plus y square over y square minus 2xy is equal to, and then it would be 1 upon 0, and hence only y square minus 2xy should be 0, and from here you will get y common, and it is y minus 2x is equal to 0, or y is equal to 0 and y is equal to 2x. Since y is equal to 0 and y is equal to 2x is true for the curve, because this point is also on the curve. So now from the curve equation, the curve, we have x cube plus 3xy square minus y cube is equal to 5. So now we can say for y is equal to 0, it is x cube is equal to 5, hence x will be cube root of 5. So the first point is, one point is going to be cube root of 5 comma 0, and for y is equal to minus 2x, sorry, y is equal to 2x, it would become x cube plus 3x into 2x square minus 2x whole cube, it is 8x cube is equal to 5, and hence we can write it from here, it is x cube minus, and this is 6, 4 3s are 12, 12 minus 8, 12 minus 8 is 4, and this is 5. So 5x cube is equal to 5, and hence x will be 1, and which will give y as 2. So the coordinates of points for which the tangent to the curve is parallel to y-axis is going to be 1, 2, and cube root 5 comma 0. Now we have to see the question again. It says that find the coordinates of points. So there are 2 points. So we have 2 points. One point is this, another point is this. I hope it is clear. So let's discuss the next question. Question number 8. There is in the diagram OABCDEFG is a cuboid, we can see, in which OA is 2 units. So this is 2 unit. OC is 3 unit. So this is 3 unit. And OD is 2 units. So this is 2 unit. And unit vectors I, J, K are parallel to OA, OC and OD respectively. The point M on AB is such that MB is equal to 2 times AM. It means, and we know that this is a cuboid, so it means AB is going to be equal to as OC. It means OC is 3, so and MB is 2 times of this, so AM should be 1 and this should be 2. Then only MB will be equal to 2 times of AM. And the midpoint of FG is N. So we know that this is a cuboid again, so it is 2. This will also be, DE will also be 2 and GF will also be 2. So G to N, it is going to be only 1 unit. So first part is to express the vectors OM and MN in terms of I, J, K. So we know that vector means you are going to find the path. So OM, how can we go from O to M? It is O to A and then A to M vector. And we know that OA, along the OA, I is the unit vector. Along AM, AM is along the OA, OC, so it is along the J vector. So OA is, length is 2, so it becomes 2I cap, plus AM is 1 length and it is C direction, J direction, so it is going to be 1 times J, so only J cap. So OM become 2I plus J cap. Next is MN. Now we need to find the vector MN, M to N. So we can go from M to O, MO vector, then O to C vector, then C to G vector, then G to N vector, and we know all the direction here. So it is MO is minus of OM vector, hence it is minus 2I cap minus J cap. OC is unit vector along OC is J cap, so it would be 3J cap. CG is along OD, so it is 2K cap, and GN is along OA and it is 1 length, so it is only I cap. So we can rewrite it as minus 2I plus J, it is minus I cap minus J and 3J, so it is plus 2J cap and plus 2K cap. So now we have MN vector and OM vector. So I hope it is clear. So let's do the B part of it. B part is find a vector equation. Vector equation always looks like A vector plus T times the direction vector. Now we require to find the equation of line through M and N. So through M and the vector equation is R is equal to vector R is equal to OM vector plus lambda time, we can take T or lambda or anything, with lambda times B vector, and here the B vector means MN vector, and it is going to be OM vector, we already know, that is 2I cap plus J cap plus lambda times MN, that is minus I cap plus 2J cap plus 2K cap. So R, vector R is equal to 2 I cap plus j cap plus lambda times minus I cap plus 2 j cap plus 2 k cap is the vector equation of the line passing through M and N. I hope it is clear. Next part is find the position vector of P, the foot of perpendicular from D to the line through Mn. It means you can see M is here, N is here, and D is somewhere here with the coordinates. D has coordinates 0, 0, 2, and we have to drop a perpendicular because we need to find the foot of perpendicular from D to the line through Mn. So we need to find the position vector of P, this P. So we know that what is the vector equation, vector equation of line through M and N. It is given as 2 I cap plus j cap plus lambda times minus I cap plus 2 j cap plus 2 k cap from the B part. This is the vector equation, and hence any point on Mn will be of the type. So we can take the coordinates of P, vector P, position vector of P, we can take it as like position vector of P, we can take it as 2 minus lambda I cap plus 1 plus 2 lambda j cap plus 2 lambda k cap. Now we have the position of P also. So what we are going to do, we know that these dP and Mn, they are perpendicular. So from here first of all we will find dP, and dP vector is going to be P vector minus position vector of P minus position vector of D, and that is going to be 2 minus lambda I cap plus minus 0 is same only, 1 plus 2 lambda minus 0 j cap and 2 lambda minus 2 k cap. This is the vector dP, D to P. Now we have the direction along the Mn, line along the Mn, that is this. So if we multiply, do the dot product of dP into direction vector along Mn, then that product should be 0. Not Mn exactly, but product should be 0, and hence we will get it as 2 minus lambda into minus 1, so minus this, plus 1 plus 2 lambda into 2 plus dot product, I am doing the dot product of this and the direction vector, and 2 lambda minus 2 into 2, this will be 0 because they are perpendicular, and hence from here we can simplify and see what is coming, minus 2 plus lambda plus 2 plus 4 lambda plus 4 lambda minus 4 is equal to 0. These two got cancelled and 9 lambda is equal to 4. This will give you lambda is equal to 4 by 9, and as soon as we get the value of lambda, so we have the position vector of P, and hence position vector of P, let us say OP, I will write OP, position vector of P is OP, and it is 2 I cap plus j cap plus 4 by 9 times minus I cap plus 2 j cap plus 2 k cap, or we can write it as 2 minus 4 by 9, 2 minus 4 by 9, 9 to the 18 minus this 14 by 9 I cap, 1 plus 8 by 9, 1 plus 8 by 9 is 17 by 9 k cap, sorry j cap, and the last one is again only 8 by 9 k cap. I hope it is clear, you can see it clearly, I will make it above. 14 by 9 I cap, 17 by 9 j cap and 88 by 9 k cap. I have added the like terms from here. I hope it is clear. Let's do the ninth question. Ninth question is fx is given by this and we need to express in the partial fraction. So we can see there are three linear product of three linear factors in the denominator. Then we can take it as 2 plus 11x minus 10x square over the same 1 plus 2x into 1 minus 2x into 2 plus x as a by 1 plus 2x plus b by 1 minus 2x plus c by 2 plus x. We can multiply throughout by the denominator. This denominator, what we'll get? We will get 2 plus 11x minus 10x square is equal to a times 2 plus x into 1 minus 2x plus b times 1 plus 2x into 2 plus x and plus c times 1 plus 2x into 1 minus 2x. So now we have to find the value of a, b and c. So let's take x is equal, we'll put x is equal to minus 2 so that we can get rid of these two terms. So x is equal to minus 2 will give you 2 minus 22 minus 40 is equal to, this is gone 0. So c times 1 minus 4 into 1 plus 4, or it is 2 minus 2 22, it is minus 20 and minus 40 it is minus 60 is equal to, it is minus 3 and it is 5, 5 3s are 15, minus 15c, which will give you c as 4. We have c as 4 now. So let's put x is equal to something else. We can take x is equal to 1 by 2, x is equal to 1 by 2, so that we can get rid of this and this. So it is 2 plus 11 by 2 minus 1 by 2, 10 by 4, 10 by 4 means 5 by 2 is equal to, a term is gone, b term is only left, so b into 1 plus 2 by 2 it is 1, to 2 into 2 plus half it is 5 by 2, and hence it is cancelled, so we left with 5b, and here it is 11 minus 5, 6 by 2 is 3, so 3 plus 2 is 5, so 5b is equal to 5, hence b become 1. So we got another variable, another constant. Now next, the last one is we'll put x is equal to minus half. If we'll put x is equal to minus half, we will get 2 minus 11 by 2 minus 5 by 2 is equal to, this term is gone, this term is gone, only this is left. So a times 2 minus 1 by 2 into 1, so you got it as 2 into 3 by 2, a into 3 by 2 into 2 cancelled. So from here minus 11 minus 5 minus 16 by 2 is minus 8 plus 2, minus 8 plus 2 is minus 6 is equal to 3a, and hence a become minus 2. Now we got all the variables, all the constant a, b, c, hence the partial fraction of this fx we can write it as minus 2 over 1 plus 2x plus 1 over 1 minus 2x and plus 4 over 2 plus x. I hope it is clear. This is the partial fraction of the given function. Let's do the b part of it. B part is, hence obtain the expression of fx in ascending power of x up to and including the terms in x square. So we will copy the same function here. Now we have this, so we can rewrite it as minus 2 into 1 plus 2x power minus 1 plus 1 into 1 minus 2x raised to the power minus 1 plus 4 into, it is x, So 4 into 2 plus x minus 1. I think I have written 4 here, it is x. So now we use the binomial expansion for the negative power. So it is minus 2 into, we require till x square, it is 1 plus nx, that is minus 1 into 2x plus n into n minus 1 over 2 factorial x square, so that is 2x square. Now we will not write next term, so leave it as it is, plus 1 minus 2x power minus 1. So my 1 plus minus 1 into minus 2x plus minus 1 into minus 1 minus 1 minus 2 over 2 factorial into minus 2x square, and the next term we don't require. And for the last one, 4 plus 2x to the power minus 1, we will take 4 common, 2 common, it will be, I will write it 2 plus x to the power minus 1 as 1 upon 2 to the power 1 plus x by 2 to the power minus 1. It is like 2, you take common, we will get this, and so that we can use the identity, and it will become 4 by 2 into 1 plus minus 1 into x by 2 plus minus 1 into minus 2 upon 2 factorial into x by 2 whole square. Next you don't require, so leave it as it is. It is 2 times. Now we will simplify and find the answer. So it is going to be minus 2, I am multiplying here, so it is minus 2 minus minus plus 4x, 4, this 2 will be cancelled and minus, so it is minus 4 2s are 8, 8x square from here and so on, plus from here it is 1 plus 2x minus this 2 will be cancelled, so plus 1 and plus 4 from here, so it is 4x square and so on, we don't write it. Next is 2 into 1 is 2, 2 into this it is minus x, 2 cancel, minus minus plus 1 into 2, and this will be x square by 4, so it become x square by 2 and so on. So we are going to write the ascending of power. It is, we can see it is minus 2 and plus 2 cancelled, only 1 is left, 1, and 4 to 6 minus 1 5, 5x, and minus 8 plus 4, it is minus 4x square, minus 4x square plus half, it is going to be minus 7 by 2x square, and this is the answer till including x square and up to the x square. I hope it is clear. Note where x and y are real numbers. I can multiply the second equation by iota. Multiplying the second equation by iota, we will have 1 plus 2 iota into iota v minus iota w is equal to 3 into iota, and we know that since iota square is equal to minus 1, so we can use it here, and it can be written as iota minus 2 times v minus iota w is equal to minus 3, and we will rewrite the first equation below it. It is v plus iota w is equal to 5, and let's add it. If we'll add, we will be getting only v term, and that is going to be minus 1 plus iota, because it is minus 2 and it is 1, minus 2 plus 1 is 1, and minus 1, it is 1 minus 1 plus iota v is equal to 2, and hence from here we will get v is equal to 2 upon minus 1 plus iota. Now we need to write in this form x plus iota y, so we will multiply by its conjugate and divide by its conjugate. So it is minus 1 minus iota over minus 1 minus iota. So we got the numerator as minus 2 times 1 plus iota over minus 1 square a plus b, a minus b, so it is minus 1 square minus iota square, so it become minus 2 times 1 plus iota over 1 plus 1, and it is 2 because iota square is 1. So the answer for the value for V is equal to minus 1 minus iota. I hope it is clear. Now let's find the value of W. So I'll scroll it up. So now, since from the second equation we can see it is 1 plus 2 iota V minus W is equal to 3 iota. So from here we put the value of V and we'll get 1 plus 2 iota into minus 1 minus iota, and I'll transfer this thing here. It is minus 3 iota is equal to W, or we will simplify, it is minus 1 minus iota minus 2 iota, and minus minus it is minus iota square, that is plus 1 and 2 minus 3 iota is equal to W. Now we are going to add and subtract the like terms. So minus 1 plus 2 are like terms, so it is plus 1 minus 1 minus 2 minus 3 is minus 6 iota. So W is equal to 1 minus 6 iota. Now we have the answer of value of V and W in terms of X and I, Y. Or we can rewrite as the X plus, so we can write the final answer in this way: minus 1 plus iota minus 1, and W value is 1 minus 1 plus iota minus 6. And here is the B part. Here is the B part. On an Argand diagram, sketch the locus of point representing the complex numbers satisfying this. It means we can see it is z minus 2 plus 3 iota modulus is equal to 1. It means it is of the type a center 2, 3 and radius 1. This is a complex number. Like we can say that it represents a circle with center 2, 3 and radius 1. So we need to sketch it. Let's draw the x-axis and y-axis. So we can take a circle, and that circle will be this circle is having the center as, suppose this is 3 and this is 2 on x-axis, and this is origin. So this point is 2, 3, it is a center and its radius is 1, and hence this is the Argand diagram of this complex numbers. And the B part, let's discuss the B part. B part is calculate the least value of argument z, least value of argument z for the points in this on this locus. So we can see from here directly that it should be this. If you draw a tangent on it, then only this will be the least argument. Otherwise whenever you'll go anywhere else, it will be more than this. So what we are going to do, we are going to find this angle, that is going to be the argument, and for that case we require the line, this angle we can join O to C first of all, O to C, and it is going to be 90 degree, and hence this will be, we can get it with the help of, this is 2, this is 3, so with the help of tan, this angle is tan theta is equal to 3 by 2, or theta will be tan inverse 3 by 2, and this angle. For this angle we require, we know that this is a tangent, so it would be 90 degree, it is 1. So we require this length and OC, suppose this is C, so OC is going to be root 4 plus 9. So OC is equal to root 13, and this is 1. So in triangle, let's say it is M, in triangle OCM we can see sine of angle OCOM, sine of angle COM is 1 over root 13, and hence angle COM is sine inverse 1 over root 13, and hence the least argument or required argument of Z is equal to bigger angle, that is tan inverse of 3 by 2 minus sine inverse of 1 over root 13, and we will calculate with the help of calculator. It is going to be 0.701 and so on, so it is 1 and more than 5, so it is going to be 0.702 radian, and we can calculate it in the degree as well. It is going to be 40.2 degree. I hope it is clear, and this is the end of this paper. I hope you must have got all the things. Thank you so much. See you in the next video.